Hello and welcome back to Precalculus 1, take 2 for 7.1 systems of linear equations in two variables. This is something you learned before, so now you're going to have a quick review of three methods of how to deal with a system with two variables. So let me just check if the stream is moving. Yep, stream is moving. So we have a system that says 2x minus 3y is equal to negative 4 and 2x plus y is equal to 4. This system can be solved graphically. Any system with two variables can be solved graphically by graphing two lines that are presented to you, where their intersect will be a solution. So we can have three situations when the lines intersect at a point, solution, which is xy. When the lines are parallel, which is no solution. And when there is only one line, so they graph on top of it. So let me just let line 1, line 2, line 1, line 2, and this is line 1 and line 2 at the same time. This is infinitely many solutions. So these are the three possibilities. I will not go through graphing method because we don't have to. We rarely graph these because we have the two analytic methods, which are substitution and elimination, known as Gauss-Jordan elimination, elimination or addition method. Those are the names that you might heard before. Bless. So let's talk about substitution method first. So for substitution method, we are going to locate, so 2x minus 3y equals negative 4. Let me just write this down. 2x plus y is equal to 4. We are going to locate a variable which has the coefficient of 1. This one in this case. And we are going to solve for it. So y is equal to 4 minus 2x. And then you're going to plug that in the other equation, getting 2x minus 3 times, and your y is 4 minus 2x, equals to 4. No, negative 4. So what I have done is I solved the second equation for y, and I replace the y from the first equation with what y is from the second equation. And now if you look at the resulting equation, I have only x variable. So 2x minus 12 plus 6x is negative 4. 8x is equal to 8. And finally, x is equal to 1. And then I'm going to use the equation y equals 4 minus 2 times x, which is 1, to give me that y is 2. I write 1 comma 2, which is a solution. So for substitution method, you see an entire method right there. For substitution method, you locate where the single variable is, right, with the one coefficient 1. In this case, on the second. And then you solve for it, plug it in the other equation, and then solve. It's very systematic. Again, you know this. Now, what happens if none of those coefficients are 1? Well, in that case, you use elimination method. Elimination method. We have the same problem. So we have the same problem, say. So just imagine that this problem does not have any of the x's or y's with the coefficient 1, even though it does, but let's say it doesn't. Elimination method is the method to go. And the reason is, if you are solving substitution method and you don't have 1 in front of one of the variables, you will end up with fractions, and then good luck. I know how much you love fractions. So elimination method will allow us to actually add and subtract equations to cancel one of the variables. In this state, if you look carefully at the equations, simply subtracting equations will eliminate x, because 2x minus 2x is 0. So if you are to subtract these equations, and I don't care whether it's 1 minus 2 or 2 minus 1, right? Which one is going first, which one going second? Either way you look at it, they will subtract into expression which has no x. So let's say you want to do equation 1 minus equation 2. Well, 2x minus 2x is 0. Negative 3y minus y is negative 4y. And then negative 4 minus 4 is negative 8. Y equals to 2 immediately. So if you subtract these two equations, you will do this immediately. And now plug these two into any equation and calculate x. You can, let's use the second equation. So now 2x plus 2 is equal to 4. 2x is equal to 2. X is equal to 1. And here it is, the solution we know from before. 1, 2. So elimination method worked well. I'm just going to do one more example of this. Again, this is a review. So here it is. Now what happens when nothing matches? You don't have a single x or y to do substitution, and you don't have any of these line up for quick subtraction. 3x plus 2y equals 48, to make the matters worse. And then 9x minus 8y is equal to negative 24. Okay. So we do not have a coefficient 1 in front of any of the 4 xy, xy. So what would you propose to do? Yes? Why negative 3? Because you are preconditioned to add them, right? You can multiply by 3 and then subtract them. The goal is to try and minimize numbers. So these guys seem like they are lined up, and if you multiply this equation by 4, you will have 8, and then they add to 0. But you're multiplying by 4, which is more than multiplying by 3, which creates smaller numbers. So by multiplying by positive 3, you're going to get positive 9 here, and then you subtract equations. You can either add or subtract equations. It doesn't matter. Well, it matters depending on what you want. So if you multiply by negative 3, you will be adding two equations. If you multiply by 3, you will subtract equations. And just because you are not used to subtracting equations, I'm going to multiply by 3. And you go ahead and multiply by negative if you want, and then add them. I don't care. So I'm multiplying top equation by 3 to fix the coefficients. So I have 9x plus 6y equals to 120, 136. No. 24, 144. 144. And I'm copying equation below because nothing has changed. And now I'm subtracting equations. I'm going to say equation 1 minus equation 2. So 9x minus 9x is 0. 6 minus minus 8 is positive 14. And 144 minus minus 24 is 168. So y is 12, I hope. Good? And now I am going to plug this y equals to 12 in any of the 4 equations that have both x and y. Now, obviously, you don't want to use the one with 144. You're trying to do as less work as possible, so first equation should be common sense. So I have 3x plus 2 times y is 24 is equal to 48. 3x is 24. X equals 8. And there it is, solution 8, 12. If you were to graph these two equations carefully on the graph paper, using rulers and everything else, you will have the intersection at 812, point 812. So this was a quick review of what you... Oh, and by the way, if these calculations give you either, let's say, a 6 equals 6 or 15 equals 15, then you have infinitely many solutions. And if it gives you 7 equals to 9, then you have no solution. That's how you spot those cases. Remember, we have 3 cases. A solution, which is what we had in 3 examples, or no solution when the lines are parallel. Every time when there is no solution, either one of the 2 calculations will give you mathematical fallacy, which is 7 equals to 9 or 1 is equal to -3. They will give you something weird like that. In that case, once that happens, you know there is no solution. And then the third possibility is when you get a correct statement, like 3 is equal to 3 or -5 is -5. In that case, infinitely many solutions, which means you can find the relationship. Well, there's more to it later on in linear algebra. So this was the review for 7.1. We have 3 methods: graphing, which we try to avoid because it requires precision and so on. And then we have substitution. If one of those x and y's is 1, you can quickly deal with it with substitution. And then elimination, which is good when you don't have those x's and y's with coefficient of 1. That's it for this, and then we're going to jump into 7.2. Bye, stream.